Everyone. Welcome to our YouTube video presentation on pneumonia detection using deep learning. In this video, we will take you through an exciting project that focuses on pneumonia detection using deep learning techniques. Before we begin, I would like to express my sincere thanks to Professor Dr. William Hahn for his invaluable guidance, supports, and instruction throughout the project. I would also like to acknowledge my friend, Mr. Fransis Boatang, who provided valuable insights that motivated me to move forward. Their contribution have been instrumental in the success of this project. Now let's dive into the project highlights and understand the various components and functionalities that make this pneumonia detection system impressive. Pneumonia is common, potentially serious respiratory infection that can be detected throughout medical imaging such as chest X-rays. Deep learning has shown promising results on automating the detection of pneumonia from medical images. The main objective of this project is to develop a deep learning model accurately detect pneumonia from chest X-ray images. I have used MedMNIST pneumonia chest X-rays dataset for this project. So the MedMNIST dataset is a collection of medical images datasets specifically designed for the machine learning research and evaluation. It consists of various subsets, each focusing on different medical conditions and imaging modalities. For this project, I am specifically utilizing the pneumonia subset of the MNIST dataset. In the MNIST dataset, the pneumonia subset consists of total 5,856 images. These images are divided into three sets: train sets, validation sets, and the test set. So the distribution of images in each sets, the train set images I have here 4,682. The validation sets we have 1,044 images, and in the test set we have 130 images. So these images are grayscale and have dimension of 28 by 28 pixel. Each image represents a chest X-ray and is labeled as either pneumonia positive or pneumonia negative. So the dataset provides a valuable resource for training and evaluating deep learning models for pneumonia detection. With a large number of diverse images, the datasets allows for robust model development and evaluation. Our goal is to leverage this dataset to train deep learning model that can accurately classify pneumonia in chest X-ray images. So I will overview the code here I have written for this project. The code is written in the Python and utilizing various libraries and frameworks such as PyTorch, scikit-learn, and Matplotlib. Yeah, so the code is divided into sections, each representing a specific, you can see here is specific functionality or tasks related to pneumonia detection. So these are all the dependencies, these are all the requirement for this particular project to process the image and to train the model and for all the requirement for the project. And we can see here, this is a function to load the dataset. This section focuses on the first section of the code, which is responsible for loading the pneumonia dataset. The function, actually this function, load datasets, is used to load the dataset from the specified path. I have given you this is the path is from file. The dataset is stored as a NumPy array where each element represent an image. Yeah. Additionally, a montage of images with their corresponding labels is created and displayed to provide an overview of the dataset. By loading and visualizing the dataset, we gain insights into the images and their labels, which is crucial for understanding the data before further processing and analysis. So the load dataset section sets the foundation for subsequent sections by providing access to the pneumonia datasets for various tasks, such as training a neural network model and evaluating performance. So here you can see to the histogram. This code, this function actually generates the histogram. This basically generates the histogram. The function generate histogram is used to create a histogram to visualize the label distribution. The labels are extracted from the dataset and converted into a NumPy array using matplotlib. A histogram plot is generated with the labels on the x-axis and the frequency on each label on the y-axis. We can see it later on while we run this code. And here we can see the function to view the RGB channel and the train model. This is the most important function here. We actually train the model, and by training this model, we can get the conclusion. We can get the result. We get into the conclusion that either the given chest X-ray has pneumonia positive or negative. So the section begins, the trained model begins by defining the data directory and creating subdirectories for the train, validation, and test sets. The pneumonia dataset consisting of images and corresponding labels is loaded from the specified path. So data transformation are defined with torchvision.transforms.compose to normalize and convert the images to tensors. Image datasets and data loaders are created using the image folder and data loader classes from torchvision. So after training the code, this code, finally we get the code. It prints as the finished training. So after the training, the data sets, we save the model, and this section includes two functions: save model and load model. So this function is for save the model, and this is for load the model. So first, whatever we train in the train model, it saves that this function will save it in the system, and this will load the model what is saved in our directories we have given. And then this test neural network, the dataset loaded using image folder class and transform with the predefined test transformation. So the accuracy of the model is calculated by comparing the predicted labels with the ground tone labels in the test datasets. So this helps us, this function particularly helps us to show the test of the neural network. So how accurate is our trained model? This will help us to show it. Either this is the 100% accurate, or the 90% or 80% or less than that. What is the percentage accuracy of the model that we train will be shown by this function called the test neural network. And finally, we get the result, the result of the pneumonia detection or not. I mean, the particular X-ray image has the pneumonia positive or pneumonia negative. It will show you as the result. And final, we have the question and answers tab here, where we can start with the questions and answers. Once you get the result, then either you have the pneumonia negative or positive. If you have pneumonia negative, then what should be the for other steps that you should follow? And you can ask the questions and you get the answers from the expert system. We are integrating here the API of ChatGPT, so that you can ask the questions and get the answers from the expertise of ChatGPT. So well, we can run this code and we can see how this works. So first we install the required packages, then we import the dependencies, load dataset, all right, function to test the neural network, function to Q&A, got it. So here we see the tab here. These are the bottom created here by this code, and we can load the data set whatever we have in the system. Let me just finish running the code first. All right, so all the sections of the course are already run. Now we can load the data set. We can see these are the data set we loaded. And label the data sets. These are the level 0, level 1. These are just the labels for the X-ray images. And we can generate the histogram here. We can see this, the histogram is shown here. Here we have, in the x-axis we have label, and in the y-axis we have the frequency. We can see the RGB channel, but actually in the chest X-ray we have only the grayscale images, so we don't see here the red, green, and blue channels in these pictures. The train neural network, this will train our neural network. It takes some time to train the neural networks to make sure that it has the high level of accuracy. So it finished the training the model. Now we can save this model. It says that model is saved at model.pt. All right, so let's load that model now. Okay, so if the model is loaded, model loaded from model.pt. So test neural network, let's see the neural, okay, so it has the accuracy of model on the test image, 80% of accuracy. And then the result, what is the result now? Finally, the particular image of chest X-ray predicts, the model, actually our model predicts that this image is of the pneumonia affected lung. So well, this is all about the pneumonia detection AI deep learning module, which helps us to detect the chest X-ray. Either that X-ray has the particular image has the lung, the pneumonia infection or not.